sure everybody.
Is that too dark?
Alright, fine. Yeah, we can see.
You just can't see us. But
Yeah, you
you
can't
don't
see
need
our
this
faces.
video.
I
Oh,
just,
for the video.
There you go here.
Yeah.
I don't like sitting on this side.
Do you want me to switch places?
Yeah. I like that better.
okay.
I like this. It's my comfort zone.
You gotta know your environment.
Can I
You
adapt?
gotta do it here every time.
Yeah.
I don't know what the problem is. Anyway, you guys ready?
Yes.
Well, good afternoon. We are the ECEN Group. The name of our project is HealthATM. As said before, our lead advisor is Dr. Doss and co-advisor Dr. Graves, and our client is HealthATM. My name is Brianna Gunn, and I am your systems engineer and fire expert.
My name is Malcolm Miller. I work with peripherals.
My name is William Senior. I am a software developer and I'm in charge of the SMS portion.
My name is Kevin Marshall. I'm also a software developer. I'm in charge with more so the Android portion.
My name is Isaac Veal. I'm the group leader, and I also serve as the liaison for the group.
All right. So our motivation for this project is to have a unified system necessary when reporting to doctor's office. Things like if you go to a specialist for like optometrist or just your local doctor. Less time for filling out forms because it'll be done electronically through the apps, and keep all health information in a central location so you don't have to have forms transferred when you need to go see a specialist. Our goal is to complete an Android app as well as a feature phone app using SMS service.
HealthATM, as we mentioned before, is a startup company with the goals that Kevin mentioned before. Some of their current practices include merging with the fire resources in order to help build the application. In the future, well, the goal is to hopefully extend the realm of the application to low-income, clients, so that they may be able to interact with their physician through their phones.
So you're saying that right now, higher income people are able to do it? Or able to do it?
Yes, there are variations of the application, but we want to extend it out. That's the goal for HealthATM, is to extend it into low income persons.
That's that target audience. Right?
Okay. Okay, for this presentation overview, we're going to do our requirement specification. We're going to look into our functional block diagrams, our UML diagram, our test document, our work breakdown structure, the Gantt chart, and the cost summary table. For our requirements, we felt that the most important things were security, that the application is secure when transferring your data, because there's going to be things like your social security, as well as just personal data. Seamlessness, which means that when you're using the application, there's no hang-ups, there's no, well, not a lot of time when you're transferring data back and forth. Don't worry about it. Reliability, this app should always work because it's going to be used by different organizations, it's going to be used by your doctor. This is something that's important because it's about your health. Accessibility, which means that what we were talking about earlier, we're just going to go to, targeted towards low-income areas, that you should be able to always take care of yourself and not have to worry about, well, I don't have enough money. And interactivity, which means that this should be very, very, very easy to use.
Now we're going to look at our functional block diagrams just to kind of break it down for you. This is the lower level function block diagram. As implemented above, you can see the room temperature and the temperature of the patient are inputs into the system, and then that information is converted using an analog to digital converter, and then that information is sent to a BCD converter, and then it is sent to a 7-segment LED display. There's also a 9-volt battery which serves as our power supply, and at the bottom we also have the data from the pulse oximeter, which is just an oxygen reading coming from the patient, and that's read into the application, and then it's made available, as you can see, on the server and for your healthcare provider.
What level block diagram is this?
This is level 0, if I'm not mistaken.
2.
0 or 2? Oh, I think I have it backwards. I think it's level 2. Yeah, I had it backwards in my mind.
Okay, so where's level 1 and 0? What would you say? Having a whole, can I get an idea what they are?
Yes, the level, I guess this is a more detailed, diagram. Level 0 and level 1 are not as detailed, but, implemented, you will see the room temperature as well as the finger temperature and the pulse oximeter or the oxygen reading coming into one, system, and then you will see it being output to the application.
As far as the system, the overall system inputs and outputs on what?
The room temperature, the finger temperature, and the oxygen reading from the pulse oximeter.
And output,
The output is over here on the server.
what's that stand for? HCP?
Healthcare provider. Can you see it?
Yeah, we're kind
So is the server part of your system or you're communicating with the server?
Right, we're communicating with the server. The input, the information from the client is being uploaded to a server.
Okay, so how would you describe that signal? Is HealthATM part of your system?
Yes,
HealthATM
Is the
part of
application.
your app.
right.
of it's different.
So what are those two signals coming out of HealthATM?
They are the temperature that is read in from the thermometer and the reading that is read in from the pulse oximeter.
Okay, so it's that in a format that the files servers can understand.
Right.
Yeah, that's the overall goal. My bad.
All right.
So okay, so this is our UML diagram. This is for a simple use case, as if a patient was to complete a weekly checkup. They would complete a weekly checkup. They would connect the phone to the pulse oximeter or the weight scale, and they would send the data to the mobile device. They would determine the type of info that would use, and it would update the fire resource, which would then go to the fire server and HealthATM. And on the other side, the server would grab the health info from the healthcare provider. It would determine which user it was, and then update the health info, put it back on the server.
You said other side, what do you mean?
Like it will update the health info from the server, so when it gets the information, it would update the health info that they sent in.
That's happening on the server, is that the bot? It's happening on the server?
I guess we can go back to the previous diagram. Okay. I guess can you explain, the next diagram in terms of this diagram here? You say there's a bitch seen the good explanation.
Oh, you're saying correlate the two?
Right. Yeah.
Okay, so
You said grab health info from HCP. What's grabbing the info from healthcare provider?
So when you send in the information, the way our SMS works is that the person would check their blood pressure, or their blood oxygen, and they would send it to their phone through Bluetooth into a text message, and the application will format that into a text message and send it to a middleman. We're using Twilio, which is kind of a web-based where you can pull a text message and it'll go onto a website on a web server. And what we're working in is that the HCP or fire would pull that information and allow you. So if you sent in, say, Dr. Doss checked his blood pressure or checked his oxygen, he would do the app and it would put it into a text message. And the text message would then send to Twilio. And then fire would be able to pull from Twilio based on his phone number and his information, and it will update the info.
So this is two different ways of doing the same thing.
Saying it's like what's happening on both sides. So when you send it, it's what's happening on both sides at the same, kind of the same time. Like one thing's happening with the other thing is happening.
Yeah, what do you mean by size?
Oh, I'm sorry. When the user sends it in, the server is doing something as well. So as soon as the user sends it in, as soon as the information, then it's going to pull it. It's going to determine the information based on the user.
So the top is the user.
And the bottom is the server. It's a simulate. It's a use case, simulating a simple use case.
And we check out, who's involved in the
It's just the person as a client. So like so a person that's checking themselves up.
I'm sorry, I think this is the answer. No. Yeah.
I think like the side. Okay, you're saying the server. So the service in this case, is that the health ATM, or are you talking about the fire server, or are you talking about the Twilio server?
So Twilio will actually be the one that's I guess that's the middle. Twilio is actually be the middleman, so it'll be the fire server that's getting them.
Where's Julio
It's Twilio.
in that diagram? Where's that?
So as Twilio would be, it's not actually stated in the document. Twilio is what's grabbing the health info.
Is that what?
Twilio is what's grabbing the. It's what the health. It's like a middleman, so it's kind of like the in between. So where the info is being sent from the client and where the info is being pulled from to be put on the fire server.
Twilio, I thought it just something that would relay text messages. It can pull the information from the server and do all that.
From my information, it can, but we would have to pull it ourselves. But it's like just that resource that we can have pull from. So we have to physically pull it. We're not pull. We would have to create the pull ourselves. Have the fire server pull it from the tool.
Okay, look.
For our test document, it was a simple Bluetooth integration test. We're going to be receiving Bluetooth data from the pulse oximeter, and we're going to be able to decipher it and show a message on the screen that the data that's on the oximeter can be displayed within the application. The next step after this test would be to have the same test with the thermometer, and then after that, unit test the entire system. In our work breakdown structure, we're nearing the end of it. As far as peripherals, we have all the peripherals purchased and assembled. The service, the SMS service and the app are nearing completion. And after they are completed, we will finalize the system integration and test.
So this is our Gantt chart, which shows a breakdown of our work for our whole semester. It has your SMS service. It has our peripherals. It has us purchasing the peripherals. It has us assembling the different parts. It has us testing the different peripherals and our expected date, which we would integrate and test our entire system, which would be our start end date would be April 11th.
April
I can't
11th.
really see.
11th.
Yeah.
April 11th, what's happening?
That's
What's happening on
what the projected date that we would be able to integrate and test all of our parts.
I can't see all the writing, but can you explain sort of like a couple of short, we got a couple of short bars in the rest of the
So this one right here and this one right here. So for the compliance, this one is shorter because we just have to make sure that it complies. So compliance one just make sure it complies with everything and it's able to run.
Able to comply with fire standards. And the other short one is test peripherals, which doesn't really take a lot of time once you have everything else completed. So that's why they're shorter compared to assembling the thermometer circuit and completing the Java code and the SMS service. Those are more strenuous tasks than testing the peripherals.
You start, so you're starting, if you can start like now, this one, that's from the beginning.
It's from the
Beginning
beginning of the
beginning-
semester.
Beginning of last
Last
semester.
Next semester,
Not
from the
till-
beginning of seeing the whole part.
Yep.
This is our cost summary table. It displays our LCD temperature meter kit and
I'm sorry, go back real quick. Where y'all at now? Where you at now?
We're in March.
Yeah, we
Say-
want.
say-
What should you be doing now? Are you,
Assembling and testing the peripherals.
that's the only thing that's happening in March?
That's the best service.
SMS service.
Right,
uh,
Job code
Java.
standard a little bit.
What about the SMS?
SMS services, we're still, it's still being worked on, but, it's kind of off a little bit by the date, but by around the 14th, we should be, done and it should be working.
That's the Twilio?
And that's with the Twilio.
What's the third one? SMS service? What else?
Compliance. Oh wait, talking about the
There's
fifth?
three, right? Are there three around this time?
Yeah.
Oh yeah.
It's the SMS, the peripherals,
And the Java
and
code.
the Java code.
Java code is the software application. SMS service goes with our SMS application that's supposed to be for the feature phone. So the development of that and compliance to make sure that's fire compliant as well as every compliance with the health profiles, fire, things like that.
Like I said before, this is our cost summary table, and it displays our temperature meter and our shield for our Bluetooth, our Bluetooth capable Arduino. The total cost was $55.94, which is well below our $250 allotted limit from the university.
Is it all you all there? And March?
So we've had to actually purchase ourselves.
Right.
Oh, that's the.
Post Assembly was already in-house, so we didn't have to purchase
Oh.
it.
So, what are the parts involved?
So the other parts, we are looking into buying an actual feature phone. It's a smartphone because when working with the Java, working with the SMS application, we found trying to emulate a Bluetooth reception on an actual computer is very tough to do. So we are going to buy an actual feature phone with activity so that we can simulate, so that we can have that functionality to send a text message and connect it with Bluetooth to the pulse oximeter.
How much you want to cost?
It was around $30-40. It was not much.
And that's unlocked, I guess, or whatever?
That's unlocked. So we would have to buy minutes per se to be able to send text messages, but just for Bluetooth. When you get to sending text messages, that's what we'll have to buy like minutes or say to actually be able to send text messages to Twilio. But just for Bluetooth functionality, we can just buy the phone unlocked. So,
So how are you gonna send?
Well, what's it? Service?
Think about like the AT&T Go phones or the Virgin mobile phones, the one that's under Sprint that I can't remember right now.
Oh, like.
Boost Mobile,
phone.
thank you, Boost Mobile.
Just
You can
a
think like
Okay,
that.
you know.
Yeah,
Yeah.
pretty much.
Okay.
Page
Page
go.
go.
You're right. Yeah.
Track phones,
I
whatever.
thought it was.
There's a lot of
So what's the timeline you getting?
I should be either Friday or Monday. So today I'm looking into it. I've been looking into it, and Friday trying to get funds together.
So, do they come with Bluetooth? Those phones come with Bluetooth?
Yeah, those phones can come. Those phones come with Bluetooth.
Be surprised. You can get an Android phone. I didn't even think about that, but you get an Android phone as a.
Maybe you get some of those phones for free.
Yeah, you can either pay for the phone and just pay for minutes as you go, and they charge some type of fee for that, or vice versa, where they
You
give
have
you the
to
phone
sign
and be
up.
like zero, but you gotta.
You have to sign up for some kind of contract or
Right.
plan to get it for free. But it's nothing free in this world.
But the phones still aren't that expensive.
What do they call them, Obama phones?
Oh yeah, okay. Those feature phones are free.
I didn't even know about
I
that.
think you have to like qualify.
Yeah, we have to
Yeah,
qualify.
I'm about to say, I didn't even know. I'm pretty sure we don't qualify.
My grandmother qualifies, but I,
Okay, that's what I thought they were talking
So the phone you saw, you can actually program it in Java?
Mhm.
about. All right, so what, y'all receiving any equipment from the company?
No. We've been in communication with them as far as how to, incorporate an analog device within the project, and that was how we came up with the monitor. Yes. But that was funded by our illustrious university.
All right, okay.
So in conclusion, we want to improve our HealthATM model, as well as to finish developing the app service and the feature phone service, that would be the SMS service, and complete testing of integration with either our thermometer, pulse oximeter, and future peripherals.
So we'd like to thank you all for your time today. If you have any further questions, this is the time to ask them now.
You really want to get that out. All right.
Any questions?
Demo, right?
Yes.
Oh, the demo.
All right.
Thank you.
Did you have any questions?
No, no, I think you answered. I can just say one thing though. Earlier when I was asking about that diagram, I think it'd be easy if you kind of label on there who the user, who is the, if not the user, provider or something. You have to distinguish right there. You had that chart that was on the questions. And then when that looked like everything's going parallel, but you made it sound like it should be in sections. So that's what the confusion came. You was talking about it in stages, but up there it shows how things are going in parallel. So maybe you should put stage 1 and stage 2 or something, because I know you might have size issues with the paper, right? But clearly label user versus input, and then maybe, stage 1, 2. I think that'd have to clear up the mind.
Okay. Yeah, because you're saying this happens, and then this happens on the server. Well, the server isn't going
Do
to
something
know
to-
that the server's going to respond to something. So obviously something had to happen first before the server can respond to it. And yes, that's a good point.
But, yeah, the point is that does imply that it's very technical, from a technical standpoint, so bottom line, yeah, I need to tighten up on the UML diagram. Make it descriptive of what's actually happening. So a lot of things that are, kind of vague as well as inaccurate.
The way it's being represented now. So in the way it's being represented now, it's not very accurate to what we're trying to convey.
Right, exactly. So, yeah, you want to make clear what you're trying to say, and when there's any questions. So, right now, there's still questions in my mind as to what the system is doing, how it's doing, and I'm not completely sure it's all from the diagram. But yeah, I'm going to demo.
Okay. Currently, we have the thermometer that's been assembled. We don't have the Bluetooth shield for that yet. Actually, Isaac created that and built that himself. We also have an Android application. The Android application can pair to the pulse oximeter. I have that in my bag. And you will see that they pair and they find each other. The application will turn on your Bluetooth radio. It will find any devices in the area and will allow you to pair to it. I'm currently still working on the application where I'll be able to send data back and forth. The code is there. I just have to be able to integrate into the entire application. And that's really it. So actually, we grab the pulse oximeter because for some reason on the phone.
Yes.
Yes. So would you rather see the pulse oximeter along with the application? Because I can show you on my phone the application or the thermometer.
Test that.
What's the test?
Text documents or the application.
You go about the show.
Yes. On that. I didn't use a emulator, mostly because the emulator takes too long in my opinion, and I have an Android device.
All right, show me, step me through filling out this document, doing the test that you have on this document. That's.
So I guess you guys gotta
I need
crowd
light.
around. Yeah, probably better than light.
All right, that presentation.
Okay, thank you. All right. Good luck.
Appreciate it.
Can you hit the light, please? Thank you.
Thank you.
Yeah, do some work on the way out.
Yeah, do some work on your way out. So here's the application. I just called it a Bluetooth demo. I changed this from the first one that I actually showed you during our last meeting before last. So enable will allow you and ask you whether or not you want to turn on your Bluetooth radio. Say yes. Somebody want to use pull this in there. Just open, it turns on automatically. So I can scan for devices. I'm just going to scan everything in the area, so it might pick up her laptop if her Bluetooth on is off or whatever. Saying it's found a known in device there, so it's still scanning. And it's a discoverable of I think about 60 seconds. I'd have to check the time frame on that. So here it is. You see the known medical incorporated 673206 is actually the number that you're going to use to pair with the device. I feel like I broke it because I was still working on this code, and I think I forgot to change it back. See.
What is it supposed to be doing?
It's supposed to pair. I think I changed the code while I was looking at it. Yeah, it did. Still found it.
All right, so
Yeah, through the test document, we said roll the program to intercept Bluetooth, which you've done. Test the program sending Bluetooth data from the oximeter. We can see the device. I changed the code slightly, but I was able to pair to it prior to that.
is this written for another display or something?
It's supposed to be a pop-up display, and I was working on this at like 7 o'clock in the morning again. So I'm pretty sure I changed something in here that made it stop working right.
I'm saying, what, are these letters
Yeah, I
overlapping
changed
or
that too. They're overlapping.
Overwrote
They're
something
overlapping.
else?
Yeah, I
Okay.
overwrote it. Because one says pair device and show data, because I was trying to add another button to show the data and receive it. That was the part that I was saying. The code is there. I have to implement it into the application. That's all.
Okay. So this is emulating the feature phone? Or?
No, this is the Android application. We don't have a feature phone. The test document was geared towards the application. We haven't purchased the feature phone yet. We haven't been able to emulate a Bluetooth service, a Bluetooth connection using just the laptop, which is why we want to get a feature phone.
So what I'm saying is this is not going to show up in your final design? The application, you said the application?
We're designing both for Android phone as well as a feature phone. So it's not just geared towards one or the other, it's towards both. The feature phone is supposed to be more so if you're in a lower income area, let's say you're not able to get to your doctor or anything like that, you should be able to use your flip phone because you can't maybe purchase a $200-300 smartphone and still send in your data for your healthcare provider.
All right, so and that's what I was asking is, so you're saying the smartphone application does not exist as it is?
What do you mean?
Does it exist?
Yeah, this
That's-
I mean, this is yours. I'm saying it's not on the market or.
Oh, it's not on the market. We're still testing and doing
Okay.
integration testing.
Okay.
I don't want to put
Are you
unfinished
talking
product
about
out there.
from somebody else? Is that what you're referring to?
Yeah, from
Oh, you
somebody
know what?
else.
No, someone did create an application similar to that. We found it was called iHealth, was it? iHealth. Yeah, application that was similar to that, but it doesn't actually utilize the fire resources, which is what we're supposed to be integrating into our project.
So it doesn't.
It doesn't utilize the fire resources, which is from our not consultant,
Our
client. Thank you, HealthATM. They developed the fire resources, which is fast healthcare and operative resource.
Oh, they developed it?
No, they developed it.
Well,
HO7.
HO7.
Right. So what are they using in place of fire? The other. Are they actually updating health records or the other application? That
It's, to my understanding, it's actually active right now. You can use it, but you can't use it in an Android application. It's not built into any Android app right now or feature phone.
Okay.
That's where our project is geared towards.
It's a new scanner that HO7 is coming out with, and
Right.
so these guys would be this would be one of the early implementations of something that actually captures this and exports it in file form.
So you're saying that right now there's some other standard that's used to update health records, or is it even possible now?
There are a variety of standards, but there's a lot of issues with interoperability.
Mm-hmm.
So FHIR is a new standard that's supposed to help with interoperability,
Okay.
so that you can grab data from this, from Aurora. So the